let's get start a new section from chapter 5, and it's going to be the last section, section 3, last section from the chapter 5. In this section we are going to discuss about these points, calculate the distance and focal length using the mirrors, equation of the concave and the convex spherical mirror, and draw the ray diagrams to find the image, distance and the object. In short, in nutshell, I can say that how the image is formed for the concave and convex mirrors, distinguish between the real and the virtual image, and describe how parabolic mirrors differ from the spherical mirrors, guys. Okay, let's get started with the first curved mirrors. We said that in the previous section we said we have three types of the mirror. First one, flat mirror, and we had the property of the flat mirror. We explained them all. Now we are in the second type of the mirror, which is, we call it concave mirror or concave spherical mirror. We can say concave mirror. In this mirror we can say inward shape of the spoon. Guys, what does it mean concave? If you have the shape which is inwarded like this is the back side of the shape, this is the back side of the spoon, for example. We call this part, we call this mirror concave mirror. That's the cave. For example, cave, what does it mean? Cave, you know that it's inwarded, that's why we call it concave mirror, concave spherical mirror. So it means the inward shape of the inward side of the spoon. We call it concave mirror. That's the first one. Okay, that's the definition of the concave mirror. A mirror whose reflecting surface is a segment of the inside of the sphere. Inside of the sphere, for example, that's the inside of the sphere, that's the back side of the sphere, guys. That's the back side of the sphere. Okay, and what are the properties of this image, of this mirror? Most of the time, this mirror, it will form a real image. It will form a real image. We can have 6 cases, which is, in these 6 cases, 5 of them is going to make the real image, just 1 of them is going to make the virtual image. As you see, we have 2 types, we have 2 images. In the first one, when the object is so near to the concave mirror, when the object is so near to the concave mirror, the object will be bigger. As you see, it's not the same size, bigger and upright, not upside down, and this is going to be virtual, not real, guys. But in a second case, for part B, as you see, that's the object, that's the image. Look at the image. What do you see in the image? The image is upside down, right? Isn't it smaller? It is small also. So the image is upside down, and the image is also smaller, and the image, it's going to be a real image. We will discuss about this one, a real image. Why it is real? Why the part B? Why for the image B it is a real? Why it is not real? Why it is virtual? There is some mirrors. We said flat mirror, concave and convex mirror. We have the concave mirror and convex mirror. For the concave, if you remember, we said that for the concave has a surface that curved inward, and the inside, like the inside of the spoon, that's the concave, this part concave, and the outside is the convex mirror. Convex mirror has a surface that curved outward. That's important. Inward is concave, outward is going to be convex, and outside of the spoon is going to be convex mirror. There is some terms we have to know for the curved mirrors. There are some terms we should know about them. For example, for the first term, that we have to know. Center of the curvature of the mirror, we call it center of the curvature. Center that curve it, we call center of the curvature. For example, if you look at the spoon, this part, that's the center of the curvature. We call it center of the curvature. Center of the curvature. That's it. Okay. And second one, that's the center of the curvature. Sorry, that's the center of the curvature. For the second one, the line passing through the center of the curved mirror is called optical axis. This line, we call it optical axis, which is going straight through the center of the curvature. Okay, this line we call this line center of the. We call this one optical axis. C, capital C, stands for the center, and the principal optical or axis passes through the mirror we call pole. This point we call it pole, P. This point we call it P, pole. Okay, this is going to be P, pole, if it is the mirror, this circle. And the focal point we call it the point which rays parallel to the optical axis meet in the is called the focal point. For example, this point we call it focal point. Anywhere where the rays are going to intersect, all the lines are going to intersect, we call it focal point. Guys, have a look at this image. You know, that's kind of satellite. The light is going to hit the surface of the satellite and reflect it back at one point. This point, which is we call L, and P, this point, it's going to be equal to the focal point, capital F. Guys, capital F is stand for the focal point. Capital F, it stands for the focal point. And the distance from the focal point, to the pole, the distance from the focal point to the mirror to the pole, this distance we call it focal length, guys. We call it focal length, small f, not capital F. Okay. The location of the focal point depends on the shape of the mirror. That's the note, you have to know that. The location of the focal point. If you have a wide curved mirror, you're going to have a long focal length. If you have a small curved mirror, you're going to have the small focal length. Okay. I will repeat again all. And this parallel line, which is passing through the center of the mirror, we call optical axis. The center of the curvature, center of this curve, when you complete this curve, when you completed this point, we call it center of the curvature, C. The distance, distance between the pole to the focal point, we call focal length. The focal length where all the lights are going to hit in one point, we call a focal point. This point, which is we call the light passed through the mirror, is called the pole. Okay, pole. One note you have to know that from the pole, to the center to C, we call it radius. Radius, guys. You know that from the pole to the center we call radius. So focal length is going to be equal to radius divided by 2. This note is so much important. If this part all is going to be r radius, half of it is going to be equal to focal length, guys. It's going to be equal to focal length. Don't forget this one. This note, we are going to use it. Stay with me. We are going to use it for drawing some images. Now let's get started with this one. let's just send this one away. And now, guys, we have some specific rays for the mirrors. We will talk about the concave mirror, not the convex one. So that's why I'm going to send this one back. Some specific rays, some properties of the concave mirror. We said this point is going to be focal point. This is focal point. This is the center. That is the pole. Okay, and that's the optical axis. This line is going to be optical axis. The first rule about the concave mirror is said that one. First one, if the laser beam, if the one light goes to the concave mirror parallel to the principal axis, when it's parallel, look, when it goes straight to the mirror and it's going to reflect that, it must be reflected back through the focal point. That's the rule. When you send the light straight and parallel to the optical axis to the mirror, and it's going to reflect it back, it's going to be reflected back through the focal point, guys. It must be. That's the first one. When you send it parallel, it must be reflected back through the focal point. Don't forget this one. The second rule is opposite of the first rule. When you send the light through the focal point, look, the light ray send it through the focal, right? That's the focal. The light send it through the focal. When you send it through the focal, it's going to hit the mirror and reflect it back straight and parallel to the optical axis. Look, this is parallel to the optical axis, isn't it? So when you send it through the focal, if it is the focal, it must be reflected back straight. That is the rule number 2. For the first one, we said when you send it straight to the mirror, it must be reflected back through the focal, right? But for the second one, we will say when you send it through the focal, it must be reflected back straight and parallel to the optical axis. Okay, the third one is quite easy. You know that's the center of the curvature. That's the center. We said from the center to the mirror is going to be equal to the radius. So when you send the light through the center, it must be reflected back from the center. So when you send it through the center, it must be reflected back same way, no more directions. So when you send it like this, it must be comes back like that. Anywhere you like, send it through the center, it must be comes back from the center. Okay, so parallel, it must be coming back through the focal, and when you send it through the focal, it must be reflected back as a parallel. When you send it through the center, it must be comes back from the center. The fourth one and the last one, when you send the light through pole, look, that's the light is coming and it's going to hit the pole, reflected back like a flat mirror. At this point, it's going to be reflected back like a flat mirror. I mean that if this angle is 25, this one must be 25. That is the last rule. That's the last formula. Last rule, last specific rays for concave mirrors, guys. If you remember, we said we have 4 specific rays for concave mirror. We're going to have 4 specific rays for convex mirror. I will explain later in another video. We will combine these 4 rules, 1, 2, 3, and 4. We will combine them all in one image, in one object. When this all lights, all beams are going to intersect at one point, we will have the image. If they are not going to intersect in one point, we are not going to have the image, guys. I hope you understand this 4 rules for now. Okay, that was the 4 specific rays for the concave mirror. Guys, have a look at this one. If you remember, I said we have 6 forms, 6 types of the forming images for the concave mirror. For the concave mirror, we will start one by one. Look, for example, you have the concave mirror. That is the first case. You have the concave mirror. You have the concave mirror, and the object is far away from the mirror. We will call it the object is going to be at infinity. Configuration, it means the object place. The object is at infinity. Like what? Like the previous example that I show you, that like the radar, like the radar that I show you, that I showed you. In the radar, the light is coming from the sun, and the sun is far away from the surface. That is why all the lights are coming. Look, all the lights are coming, and they are going to intersect at one point, which is, we call it focal point. Look, F, focal point, guys. So when the object is far away from the mirror, when the object is far away from the mirror, we are going to have the image at focal point, because all the lights are going to intersect at this point. We call it focal point. That is the first case. That's the first case, when the object is at infinity. In the second case, we will come back, we will come closer to the mirror. Look, what we said? We said we will have focal point, we will have a center, and this is behind the center. Look, when you have the object, the object is behind the center of the curve, behind the center of the curve. Object outside of the center or behind the center. What we will see? What we will see? For example, you have a spoon. You just looking to yourself through this spoon. You see your face is upside down and smaller. How this one is formed? Geometrically is formed like this. Look, if you remember, we said 4 rays. We had 4 rays, 4 light, which is, we said it. First one, look, the first one, we said when you send a light straight and parallel to the optical axis, and the light is going to hit the mirror, reflecting back through where? Through the focal point. Look, reflect back through the focal point. Okay, that's the first one. Second one, what we said? Second one, we said when you send a light through the focal, it must be reflected back parallel to the optical axis, right? Isn't it parallel to the optical axis? Yes, it is. Look, the first one and the second one is intersected at this point. Wait a second. Third one, what we said? For the third one, we said when you send the light from the object and through the center of the curvature, isn't it the center? We send the light through the center of the curvature, it must be reflected back same direction. It means reflect back through the center. Now look, all the lights, all the reflected rays are going to intersect at which point? At one point. Look, this point. So if this one is the head, so this one must be the head. If I do the same process at this point, anywhere else that I like, I will see these points. So look, all the rays intersected at one point, which is the head of the object. We can do it for the leg of the object. We can do for any part of the object. Now, all the rays are intersected at one point, which is, we call it intersection point, and the point that the image is formed. Look, the image is formed where? Between where? I will clean some of them. The image is intersected. The image is intersected at point, which is between the focal point and the center, right? So that's the property of the image. The image is formed between center and the focal point. That's the first. Second one, is the image is inverted or not? Yes, it is inverted. It is upside down. Look, it's upright. It's upright, but this one is upside down. The image is upside down, guys. The image is between center and the focal, and it's inverted, or we can say upside down. Down. And is written magnification less than 1. It means smaller. Magnification less than 1, it means smaller. And we can see by our eyes. Isn't it? Smaller. Look at the object. Look at the object. Look at the object and look at the image. Which one is bigger? Of course the object is bigger, the image is smaller. And we said it is going to make a real image. A real image, I mean this. Look, the image is formed in front of the mirror. When we are looking to this mirror, to the spoon, we can see the images over the surface. But actually, geometrically, it is in front of the mirror. And that's why we will say it is a real image, guys. If it is formed at this part, anywhere else, at this part, we will call it not real. Not real, guys. But if it's formed in front of the mirror, we will call it a real image. Okay, that's the second part of the concave mirror. Let's explain this third case. The third case of the concave mirror. What if we put the object? What if we put the object at the center of the curvature? Look, that's the object. You know that's the object, and that's the center of the curvature. That's the center of this curve. Center of this curve. Okay. Again, we will come back to the specific rays for concave mirror. First one, if you remember, we said when the light comes straight to the mirror, it must reflect it back through the focal point, right? Look, it reflects back through the focal point and goes away. That's the first one. For the second one, when we said, second rule is said that when you send the light from the object, from the eyes of the object, from the head of the object, when you send it, and you send it through the focal, it must be, there is no way, it must be reflecting back parallel or straight, parallel to the optical axis. Look, this is parallel with this one. And then the two rays, both of them, is going to intersect at which point? It's going to intersect at this point. So this point is the place of the image. When the rays, two reflected rays, are going to intersect at one point, which is, we call this point the image, the place of forming image. This point is the place of the image. Okay, now let's come to the properties. Look at the image. That's the object. That's the image. Did they have the same size or not? They have the same size. So it means it is not a smaller. Magnification equal to 1. It means it's the same size. Same size. Not smaller, not bigger. Okay. Is it upside down or not? The image. The image, is it upside down or not? Yes, of course, it's upside down. It is not upright. This is upright. The object is upright, isn't it? Upright. But the image is upside down, or we can say inverted. Where is the place of the image? Isn't it at the center? Yes, it is at the center. It is at the center. And the most important one is a real. The image is real. Why? Because the image is formed in front of the mirror. That's the in front of the mirror. The image is formed in front of the mirror. That's why we call it real image, guys. Let's come for the case number 4. For the case number 4, we will have, for the case number 4, look, for the first case it was at infinity, second one it was outside of the center, third one it was at the center. Now we will put the object in the case number 4, we will put the object between the focal point and between the center and the focal point. Look, that's the object. It is between where? Center and the focal point. It's written between center and the focal point. Let's see. If you remember what we said when you have the object and you send one ray parallel straight to the mirror, it must reflecting back through the focal. Now it's reflected back through the focal and it's going to goes away. Okay, that's the first one. Second one, what we said, when you send the light through the focal, it must be reflecting back straight, right? And reflected back through at the straight line, as a straight line. So now I see that the first one and the second one intersected at one point. I don't need to look at the third one. 2 is enough. I can have 2. It's enough. So first one I send it parallel, reflected back through the center focal. Second one I send it through the focal and reflected back parallel. And then they intersect at one point, which is, we call it the point of the image. So it means the image is formed. Now you tell me, is the image is bigger or smaller? Is the image upside down or upright? Is the image is real or virtual or not real? Look, because the image is formed in front of the mirror, we call the real image. Okay? And the image is inverted, right? The image is inverted. And we wrote the magnification bigger than 1. Bigger than 1, it means the image is bigger. Bigger than what? Bigger than the object. Look, that's the object, that's the image. Look at the object, look at the image. Which one is bigger? Look, the pen, object, look at this one. Of course, the image is bigger. And the place in here is written at C, but it's not correct. It's behind C, outside of C. Outside of center. Outside of the center. So it's real, outside of the center, and it's inverted, and it's bigger. It is getting bigger. Okay? And let's go ahead with the last case of this concave formation. The last case, let's clean this one. What is not cleaning? I don't know. Okay, now the last case is that one, which is the last case number 5. What if we put the object at the focal, guys? What if we put the object at the focal? That's the focal point. We put the object over there. You know that when you put the object at the focal point, there won't be any image. No image. Why? Because of this good reason. Look, if you remember what we said when you send the light straight to the mirror, it must reflect back through the focal and reflect it back. Second one, we said when you send it through the focal, because the object is at the focal, I cannot send the light through the focal. Now I have to think about the center. When I send the light through the center to the mirror, it must reflect it back to the same way. Hit the mirror and reflect it back. Reflect back to the same point. Look, is this two lines going to intersect or not? They are not going to intersect. So it means there is no image. When the lines are not going to intersect, when the lines are not going to hit each other at this point, any point, we will say there is no image. So if I draw some imaginary lines like this, still they are not going to intersect. That's why we will say there is no image. there is no image for the case number 5, which is when the object is at infinity. So when you stand in front of the mirror, concave mirror, at the focal point, you won't be able to see yourself. Okay, the last case, which is much important one, it is the virtual one. We will explain why. Now we will put the object between focal and pole. We will say object inside focal. We can say inside focal, or we can say pole. Let's pole. So now, focal and pole, the object is between them. Anywhere else you like it, you can put no difference. First, if you remember what we said when you send the light straight to the mirror, it's going to reflecting back through where? Through the focal. Look, it is reflecting back through the focal. For the second one, if you remember, for the second one, what did we say? We said when you send the light through the focal to the object and to the mirror, it must be reflecting back straight, isn't it? So now that's the light. This dashed line is going to be the ray hitting the head of the pen and hitting the surface and of the mirror and reflecting back straight. As you see, there is no intersection between the first one and the second one, right? Let's draw the third one. Maybe we can have an intersection point. For the third one, what did we said? We said when you send the light through the center to the object, to the mirror, it must be reflecting back through the same direction. As you see for the number 3 also, there is no intersection in this site. In front of the mirror, there is no intersection. So, but when you go in front of the mirror, you will see yourself. How this image is formed? It forms like this. If I draw an imaginary line, a dashed line behind the mirror, look behind the mirror, if I draw some imaginary lines, for the first one, for the second one, if I draw the imaginary line, for the third one also, I will see that they are going to intersect at one point, which is we call the point of forming the image. That's why we call this image is virtual image. Why? Because it's a backside of the mirror. And the upright, isn't it? It's upright. The image is upright. It is not upside down. Look, it is not upside down. Is it upside down? No. And it is not at sea, it's behind the mirror, back of mirror, okay? And with the magnification of bigger than 1. What does it mean? It means bigger. It means the image is bigger. The image is bigger than the object. Look at the object and look at the image, and they are bigger. The image is bigger than the object. Bigger than the object. That is the way of forming the image for the concave mirror, guys. But we will explain them all for the concave, for the convex also, and we will have some rules for making them, guys. And then I will come back to the specific rays. If you do not understand the specific rays, how it is, you won't be able to understand this slide. If you don't understand this one, you cannot understand this part, guys. I will come again. If you send it straight, it must be reflected back through the focal point, guys. If you send it through the focal, it must be reflected back straight. If you send it through the center, it must be reflected back through the center. If you send it through the pole, it must be reflecting back like same way, same direction, which I mean that it's going to be like a flat mirror, 25 angle, it must be 25 angle. When you combine these 4 rules in this page, when you combine them all in these 4 rules, specific rays, you're going to use it in one object. In this slide, in this object, you will make an image. By making one ray, you cannot make an image. At least you have to have 2 rays. 1, 2. Okay, I hope you understand